My name is Derek Gooch. I work on Aiden's team. I'm a consulting cloud architect at Fortinet, so help our customers understand how to integrate our solutions with their cloud applications. What we wanted to talk about, again, some of the feedback we got last time was we didn't really do a very good job of explaining how the traffic was flowing and how we were inserting security services into that traffic. And so I wanted to kind of run through the lab environment today and the application that we've built and just kind of walk through what's happening. So this is the overall environment. This is a very high level view. On the right, you can see we've got an e-commerce server, and that's we use Juice Shop. We use it quite a bit because it's kind of a really vulnerable sort of, if I had an application like this in my network, it'd be a worst case scenario, right? It's very easy to hack. And it's designed that way. But what we've added to that is, as Aiden mentioned, we've added an AI agent because this is a chatbot essentially. Our customers are doing this to help their customers navigate through their products, maybe even do some e-commerce purchasing through the app. And so the AI agent is going to speak to the MCP server as well as the large language model. And then, and I want to walk through how that interaction sort of happens, because I think that helps to understand when we start talking about how the security is applied. So our customer is going to, or our attacker in this case, is going to type in juicy.forticloudcse.com into their browser, and then they're going to go and be presented with just a very simple GUI. And in that GUI, they're going to type a question: Do you have any apple juice? And so that agent actually knows already about some tools that it has because of the MCP clients that it has installed. So I know about tools XYZ from my MCP server. So it's going to take that information plus the prompt that was pre-configured, and I've simplified this prompt, right? You're a helpful assistant who will assist customers with purchasing products from our e-commerce site. Now, quite often when you look at AI agents, the prompts are much, much more complicated than that. But this one, I've sort of simplified. So the important thing to remember here is the agent doesn't really know anything other than I've got these tools and this is what the customer is asking. So it's going to send that information to our AI cloud service, in this case, our large language model, which is OpenAI. So OpenAI is going to take that information and it's going to chew on it, and it's going to say, okay, there's a tool. I'm going to call this, make a tool call, search products, and I want to look for apple juice. That traffic, the AI agent then uses an MCP client to make a JSON RPC call to our MCP server, which then in turn translates that into a standard RESTful API call, pulls the information from our e-commerce app, and then provides that back to the large language model via the agent. The large language model then chews on all that information and says, in fact, yes, we do have apple juice. 1,000 milliliters is available for $1.99. Do you want me to add it to your cart? And this is pretty standard fare, and this is exactly how the interaction would continue to move if the customer decided they did want to, in fact, add apple juice. And we're going to see, Julian is going to walk through this process today during his attacks. And you're familiar with this one, but I wanted to kind of do an overlay of that similar traffic flow onto the actual environment. So we've got this deployed in AWS as a series of microservices. And so we did that for the purposes of segmentation. And also, we're using the transit gateway, as you can kind of see in the diagram. That's the thing in the center if you're not familiar with AWS iconography. All traffic that moves between our VPCs, our traffic or our application VPCs, if you will, is sent to the security services VPC, and whether it's a proxy in the case of FortiWeb, or whether it's some other kind of traffic, internal segmentation via FortiGate, that traffic is inspected in the security services VPC. So when the attacker logs into juicy.forticloudcse.com, they're actually, that is associated with a public IP address, which is on FortiWeb. So that's our web application firewall, as Aiden mentioned, web application API firewall. And I'm not going to get into great detail about the protections we have in place because Shrija is much better at that than I am. So she's going to talk in pretty good detail about how we're defending against these attacks. But when the attacker is logged into the GUI, they're logging in through FortiWeb. FortiWeb is also serving as a reverse proxy for the traffic between our AI agent and our MCP server. And the same thing goes, FortiWeb is also proxying the traffic between the MCP server and our application VPC or our e-commerce server. And so this gives us an opportunity at all of those steps to insert layer 7 OWASP protections for that traffic. We also have traffic going out from the AI agent to the FortiGate. And again, I'm sorry, not to the FortiGate, to the large language model. And we have all outbound traffic in this environment going out through a FortiGate. And we do that for a couple of reasons. We are able to insert layer 7 security services by sending that traffic through FortiGate, and we're able to do intent-based dynamic policy. So we learn metadata information about the various devices, and then we can create a dynamic security policy based on what we need that device to be able to do. And so that's kind of a large part for the outbound. So, and again, Aiden mentioned FortiCNAP. In this case, we're going to be looking at some anomalous traffic. We're going to see, somebody's logging in from a different location, and among other things. But that information is going to be shared with FortiSOAR. As well, you can see FortiAnalyzer. So, FortiGate and FortiWeb are sending logs to FortiAnalyzer, which is parsing them into events and then sharing that with FortiSOAR. And ultimately, FortiSOAR is what we'll use to do an automated mitigation. And so that being said, one thing I was thinking about your question, and I think the big thing about what's so different about this protecting this traffic, I wouldn't say it's super different. It's just that if you think about it, the agent is a new attack surface, and that's the thing that we're going to sort of see. And of course, with that new attack surface, there are some new challenges, as Aiden mentioned. All right, demo time.
Woohoo! So, demo time. Hey, I'm Julian Peterson. I'm your bad guy today. And maybe some of you may know I tried to break into Sricha's juice shop already multiple times. Luckily for her, I never really made it that far. But I'm happy that I still got my juice at the end. And well, today is my new attempt to exactly do that again. Let's break into the juice shop. And for that, I already prepared, and maybe just to demonstrate you how a juice shop can look like. We fortified it a little bit, just because for fun, but Sricha has a really good juice shop here. I also have my own, but it's not that cool. And my challenge was always, she's a competitor. So my idea initially was, I think it was now 2 years back, to buy all her juice, sell it on my platform. Because she's out of stock, I can now increase the price. It's a pretty tricky thing, but that was the initial idea, and I didn't really succeed on that. And the idea for today is, you have heard it already, I don't know about it officially, there is a chatbot nowadays. And what I've learned, and I think we also learned that for many years ago, with chatbots, they make our life pretty easy and allow us to buy like cheap cars, like for $1. You can get your Chevy today, or maybe you can get even free flight tickets. And my idea is, hey, it seems like that there is a big gap in security on when such chatbots are added, because it's like, you can do whatever. And well, here we are. We have a little chatbot. And the neat thing here is, it's like we can start with, hey, what can you do for me? Right? I don't know. It's like, let's be surprised. What can we do with the chatbot, actually? Fair to say, first of all, I hope really the demo gods are with us today. We tried it 5 times and had 5 different results. So LLMs are pretty interesting. But we got a response, at least for that answer. It's like pretty interesting. So we can search for products. We can log in. Sounds interesting. We can look for reviews. Okay. We can do advanced requests to an API. It gets even better. And we can share helpful usage snippets and tips. Okay, fine. But we can log in. Okay, which information do you need from me to log in? to log me in. So because I think that's now an interesting question, what can we do with that? Because when we look, such a chatbot is quite often like it's an assistant, right? It should help us. And what do we need? An email and a password. If enabled, and I think that's a really good point, 2FA. I really would recommend that. I'm not sure if I would share it with a chatbot, but that's up to you. So the good thing here is, well, let's task our friendly assistant to log us in. Or maybe our username is 1 = 1. No one knows, right? Let's see. Why could that work? So an interesting part here, last year it didn't succeed because the web page itself is protected by a web application firewall. So we do input sanitization. But the chatbot, where is it located in the whole construct? Usually it sits side by side, maybe the tool server in that case, to the juice shop. So there is no segmentation in between. There is no new boundary in between. Either the application is patched and protected against SQL injection, or maybe not. Oops. Like we can see here. Thankful enough, I'm now the admin of the shop. And well, Sricha, what should I say? It worked again. What happened? I mean, we discussed it 2 years ago. You should have figured it out, right?
Yep. Hi everyone. I'm Srija Alam. Julian, yes, of course. So welcome back, my friend. I just want to go back and share my screen and let's see what I got for you. 1 second.
I was hoping you're catching me this time directly at the beginning.
All right. Yep. So Derek and I were super busy with our juice shop, right? So let's dig into the FortiWeb, right? This is the FortiWeb, which is our web application and API protection firewall. And if I go into the log access and then the attack log, Julian, I already see you here. You see that? That's your request or the traffic, and it's in the attack log, meaning we do see you. The reason why we didn't block you is because you are in the policy is in the monitor mode. So just to explain what the monitor mode is, right? We do have multiple policies on the FortiWeb. These are reverse proxying and also applying protection profiles. Like Derek mentioned, everything, all of the MCP server, the agent, and the e-commerce server are interacting, and all of the traffic flows through the FortiWeb. That's why we see a policy for each here. And when I go into the policy, right, it's doing, like I mentioned, reverse proxying, but also applying that protection profile here. And the web protection profile is there already. But what happened, why did Julian succeed, is because the monitor mode is turned on. So the monitor mode is just so that the administrators can take a look at the attack log and then, can see what is coming in at the applications, but it's not actively blocking. That's why you're allowed, Julian. Congratulations. And the web protection profile, the one which we already have, and what the web protection profile is nothing but there are multiple protection policies that we can do with FortiWeb. And if you can see that on my screen, on the left side, we have several of these mitigations that we can apply. And the protection profile will combine everything together. And if I open this protection profile that was already there, there are multiple things that we have applied already. One is the signatures here, and not quite, but file security, few of them. But we can always enable them, right? The other thing I also want to show is on my other policy, which is that internal, not this is the external facing policy, but the internal one also got some machine learning running. So again, there is a protection profile here, but if I go into API protection, we do have this machine learning running. And if I go into the API protection, we do see it's running for two of these applications or policies, right? And dig deeper into this, do see some information about the machine learning models running. So what happened here is that the attack was blocked in first place, but again, it's monitor mode, so we didn't see a block. But if I go back into the log access and attack, let's dig deep into this machine learning attack, right, that was generated. So what we see here is Julian did use the REST API call or the attack that he generated was targeted at this URL. And the message says that there is some violation and we could see that raw body says this is the email and the password that he has used, SQL injection payload. And how did it build? How did it start working, right? So I'm just going to go back to my slides to explain how the machine learning API discoveries work. So what we do is the AI-powered discovery or machine learning starts by learning normal application traffic here. The FortiWeb will learn how the user interacts, what kind of context the user is using, and also what data the data flows looks like. And then it builds a machine learning model there. And once the machine learning model is built, and then there is this kind of risky, fishy traffic that comes in. We are not just flagging those alerts, but what we do is evaluating those alerts. So instead of creating this alert fatigue by raising an alert for each and every threat, we are evaluating and comparing these threats with our backend FortiGuard database. And then we are taking the decision either to block based on the severity level and the vectorized values of this payload. And immediately we are remediating by applying this block, alert and deny, or blocking these requests, and taking the necessary actions. Not only that, now we have Derek, we have an FortiAI assistant on our FortiWeb, so just makes our job easy to see what kind of alerts or what kind of attacks are coming in. So going back here again, if I analyze this with the AI assistant here, it's explaining us what has happened in the attack log. So it's taking a little bit of time here by analyzing this, but we should be able to see that it explains it's a SQL injection attack. It also explains that it's there is some violation in the model API, and also gives us some recommendations of how to fix it. So yeah, see a lot of information, Julian. I just even updated everything now that you're here. So yeah, giving us the SQL injection payload, that there is this login API with malformed input, and giving us recommendations of how I need to block these requests, and also investigate the source IP. I can do several other ways, not only just this machine learning based API learning, but we can also block it with global IP block list, IP reputation, and also tighten other rate limiting endpoints, etc. So pretty cool of how it provides recommendations here. So let's again go back into one last thing of how the machine learning based API protection is working, right? We do see the endpoint is REST user login, and it did say it's not the valid email address, and it's blocking it. That's our first step, which is the schema based protection, but it's also flagging the OWASP API top 10 group, right? So I go into machine learning based API protection here and go into this model. In the path list here, we do see that model is running for the REST user login, and it's also tagging those data categories because it involves email and password. It says personal info, useful for data loss prevention. That's also a feature on FortiWeb. But if I go into here, into this view, right, we do see it did build this machine learning discovery. So it learned as the traffic comes in and build this model. And not only that, very cool is this API view, right? It's building us this OWASP, the Swagger for us. And the teams can download this, export it out, and FortiWeb is literally documenting this for us. So why does machine learning based API discovery, why is it important, right? Unlike traditional RESTful APIs, what happens is in model LLMs and MCP kind of traffic, right? They change continuously. One single update can change authentication, because we are trying to access them for inference, embedded tuning, etc. So it changes, and it's very hard to document these APIs, for example, for the developers. And not only that, the security administrators like us, we cannot stay on top of it to see what kind of APIs are documented, and are they available? Are we protecting them, etc. So we do need this intelligent map to discover these APIs. And the other thing is that there are also APIs called shadow APIs, where they are part of the code because the developers might be using for some of the coding pieces, or they are hidden and they're not actively being documented, but that just adds an additional attack vector, right? So in LLMs and MCP protocol, everything we are interacting is with APIs. So definitely needs some discovery in there to for these to be learned. The traffic needs to be assessed and build on the go, so that we can secure them. And microservices, most of the LLMs are there. Everything behind them behind the scenes is microservices APIs. So again, we do need something that is very fastly building this discovery for us and then applying this protection. And sometimes there are also temporary APIs which leave traces in the cache, which leave traces in the logs, etc. And the machine learning discovery will come to rescue. So overall, in summary, FortiWeb can help this kind of fast pre-build or fast-paced agents or LLM-based APIs to discover them. And because what we can't see, we can't secure. So machine learning API discovery will come through. And Julian, so after this speech, I just want to make sure I'm going to put you block into the monitor, from monitor mode to block mode, and let's try it again.
You think that will work?
Let's see. I'm gonna give me a second here. I'm gonna also apply the block mode to both of my policies. There you go. Monitor mode is turned off. Looking great. And yeah, try it again. I'm gonna stop share.
Let's give me another try. So back in the chat. Let's see. Just take the same attack. Let's see if our username is still available or it's already taken. Let's give it some seconds to think about it. And well, it's a bit messy, I would say, because it's from the backend injected through the MCP, but you can see it here, the URL request has been blocked.